and we're keeping up with our Numpy revisions, and we're going to go on sums and means, just a way to show those methods and to show how to use the axis in some kind of Numpy method. So what does sum do? So let's give you a reminder of what R is. Oh yeah, obviously we need to reset those things so that we can again use our array. Okay, so here we are, we have this array, and now we can call it back with this exercise. So what you can see here is that we have this array which is going from 1 to 12 within 3 rows and 4 columns, right? So we know that it's a shape of 3 and 4. So what can we do with sum and mean? Well, every array you're going to create will have this method r.sum, and if you do it, you're just going to have 78, which is the sum of every value of your array. Again, it's very fast because unlike a Python list, you're not iterating through your objects with a loop to do the addition. You're just summing up with this method, which is very practical. Then array.mean, well, you might guess it, is going to be the average of your array at 6.5. But what you can do with those is even more interesting, because now you can use the axis to tell your sum what to do, and that is going to be very interesting for us. So for example, if I do another array.sum, but I add this axis equal to something, and if you remember last video, what we saw is that you have two axes in your NumPy array. You have the axis 0 and the axis 1. The first axis going down your rows, and the second axis going along your columns, right? So axis 0 is going to go down this array 0, array 1, position 0 of the first row, position 1 of the second row, and position 2 of the third row, which is your first axis. And then when you're getting into your second axis, you're going to go in your 0, 1, 2, and 3 spot. So what does that mean for a sum? Well, if axis equals 0, you're going to get 15, 18, 21, and 24. What are those? Well, if you add 1, 5, and 9, well, you get 15, 10, 6, and 2, 18, 11, 7, and 3, 21, etc., etc. So by saying axis, what you're saying is that I want you to sum all the values that are going downwards, going on my axis number 0, going on my rows. So the first item of all the rows are going to be added up, the second item of all the rows are going to be added up, etc., etc. And then giving you a new array, this time which is of shape 4 and nothing, okay? Because you reduced your array into this summed up version, which is one row of the sum of every column. If I change it now for 1, well, guess what happens? We're doing the same thing, but instead of going down our columns through the rows for additions, we're going to add up all the rows. And by adding up all the rows, what I do is just add up every number in every subarrays. Okay, so let's do that. Axis 1, and we're getting it. Okay, 1, 2, 3, and 4 added up are 10, 5, 6, 7, 8 are 26, and 9, 10, 11, 12 are 42. So by using this axis, you can generate new numbers, new values, and you can do operations in a very specific way on your arrays in a very easy way. Obviously, it's going to work with your mean. If I use the mean here, same way it's going to do, it did the sum, it's going to do the mean, right? So 4, 3, 2, 1, which is now equal to 10, divided by 4 is going to give you 2.5. Okay, so we have here the average for every row of our table, and if I go axis 0, we're gonna have the average of the columns, right? So here we have 5 as the average of 1, 5, and 9. So that's basically all I wanted to see here, nothing crazier, but it's just a very good way and a very good reminder of what accesses are and how it works. Lots of things are going to take this access argument, so keep that in mind. Okay, now about slicing. So I'm creating this new values array here, and what slicing is going to do is just like within a Python list, is just allow you to access parts of your array in a very precise way using the usual start, stop, and step logic. So if I take values of something, I'm gonna grab a piece of that. So as usual, with start, stop, and step, you've got to remember that depending on the number of dimensions of your array, those numbers are going to go first to be used on the axis 0, so the rows, and then on the columns. So if I'm slicing just 0 right now, what am I going to get? Well, I'm going to get the axis, the first row of my table, which is the index 0 of my list, right? The index 0 of my list of rows. So I'm gonna get this 10, 9, 7, and 16, okay? Because I'm just slicing through those values. If I put a 1 in here, I'm asking for the subarray at index 1, which is the second row of my table. And obviously, this is because by default I have start, stop, and step in here. So I'm just giving an address here. If I add my dots here, what I'm gonna get is that now I'm not saying grab this bit. I'm saying iterate through the array and give me back something. And because you are indicating an iteration in here, because you have you're inducing the use of a start, stop, and a step, the stop, and step by default are going to be used. And what you're going to get here is the same thing, but then I can say that I'm going up to, oopsie, and now I'm going to get a 2D array because of this operation. So that's just something I want you to note. I'm not going to go into explanations here, but remember that here, since you've been iterating through your 2D array, you're going to get back a 2D array. But if you just ask for the one information, then you're getting back a 1D array if the object at this spot is a 1D array. Finally, the step. And for this, what I want to do is add another row, and what I'm gonna do is add maybe a 4, 6, 3, 99 or something here. Okay, my bad. I recorded a bit of this with you not seeing the actual code because of the cropped image. So just doing this back. So we will just set it up this new row. Let me do something even more noticeable, like a 78, so that you're sure that those rows are very easy to identify. By adding this row in my value, I'm going to show you examples of iterations. So for my value 0 here, you're okay that I'm getting my first row, but what if I want to go like as a stop to my value number 2? Well, here I'm gonna get the first 2 rows of my table, because 2 not being included, just like in the Python list, I'm going to get index 0 and 1. But what you can note is also that you're getting a 2D array, because slicing through a 2D array and iterating through it, because you're going to go through your multiple layers within your array, well, what you're going to get back is a 2D array too. So even if I slice it with a stop of 1, you see that I get an array of only one item, one vector, but it's still a 2D array, so its shape doesn't change. But if I remove my slicing here, I get a 1D array, and that's like an important detail for you to know, because you might want to get informations and then you do operations on them and it's not going to work, because obviously you're going to be trying to use a 2D array and multiply it with 1D array and you won't get the correct values from that. And finally, obviously, you can always just use the step by itself, and the most interesting case being using just a step of -1, because if you don't know, just like in a Python list, what you're going to do here is start from the beginning, stop at the end, but you're going to iterate backwards, so you're going to get a reversed array, just like with a Python list. So nothing crazy going on here, but adding dimensions makes it way more complicated, and this is what we're going to see with this next row here. So now what do I do to access my sub-values? Well, just like in a Python list, you can just easily go into 1 and then add another layer and just go 2, and here I'm going to get value 6, okay, because I'm at row 1, value number 6, value index 2, which is 6, okay. But this isn't slicing. There's another way for you to do that, and it's using... So you stop in your step maybe, and then you use a comma to go to your next layer, your next dimension, and here you're going to iterate through stuff. And so I could start at 0, go to the end, and maybe have a step of 2. And if I do this, I'm getting my array of index 1, and then I'm slicing and iterating through that array by using start, stop, and step. And just by dividing those two operations by a comma. So you forget very quickly and very fast how to write this, but by doing it pretty often it gets very easy and very clear. I could be iterating through my whole array backwards and then slice every other items from there, and don't even need this. And here I'm gonna get my 78 and 3, and then since it's every other object, I don't get them, and then I'm going backwards 4 and 6, and backwards 10 and 7. And if I don't do anything here and just maybe stop at 3 or 2, okay, what you're gonna get is basically the same thing, but you start at index 1, and if I do 3, you're gonna get the 3 first values of every list, and you won't and having it backwards. Okay, so this method of slicing through multiple dimensions array is not that hard, but you're just gonna work with it. Obviously, if you have multi-dimensional tensors, you're gonna add commas there to reach those different dimensions, but as I said, I'm not comfortable going too deep into that, so I think I'm just going to stop there for slicing, skip all those empty rows that I don't know what they're here for, and get into filtering. Filtering goes very well with slicing, and it's a very good introduction to what's going to be filtering in Pandas. So what you can do actually when you're slicing is that if I call back my R array here, we're going to be able to just call R and call R0, right? Without the word notations, okay? But you can also say that I want to get I want to do an operation on everything, okay? And if I do R, and we saw that in the numerical operations, if I do R divided by 2, I get my array with every items divided by 2. But what you might not know is that this works for any kind of operation, and even comparisons and Boolean comparisons. So if I say array more than 10, I get almost only falses and 2 trues. And if I do more than 8, I get this, because my array was going from 1 to 12, so it only gives true for the last row of my table. So you can get from your array not only calculations but Boolean values that you're going to be able to use in multiple manners. And this is the core system that you're going to use for filtering, because if I go down there and I do array and I'm going to slice using this command, what I'm going to send through my slice is this subarray, this 3D array, sorry, this 2D array of falses and trues, and commanding it to just slice through only the truths. And so if I do this, I'm just going to get my third row, okay? 9, 10, 11, 12. 9, 10, 11, 12, because this true is on the only values that are going to be showcased. So you can do a lot of things, and some very basic example usually people are going to do is that you're going to create a variable, so my filter, and you're going to call like array modulo 2, and what you're going to get from this, sorry, is a series of 1 and 0s, okay? And so what you're going to do is just say equal 0, for example. What you get now is your false and truths. So what happens if I use this filter in my array? Well, let's do it. And you're getting 2, 4, 6, 8, 10, 12. Why is that? Because my test up there just said that we're gonna filter through every value that is pair. Okay, every value divided by 2, that's gonna leave no additional values. So easily here I filtered through a whole array just to get the pair values, and there are multiple ways to filter through in a lot of for a lot of reasons through your arrays and getting back the values you need by filters. And this is exactly the way it's going to work in Pandas too. So it's not that hard, you just need to understand this concept of like filtering an array with another array of booleans. It's just going to tell the Numpy whether or not to showcase the value. Just a quick note for yourself, we're just getting back a 1D array in that case. So it's interesting to note that here we basically have a list that you can iterate through. And for example, I could use this as a list comprehension to maybe populate my list with only the pair values of my table to do something with it, okay? And I could have like my k is equal to x for x in this, and now my k is just a new Python list of those informations, and I can do any kind of thing with it. We don't have an Numpy array anymore, or you could just create a dictionary of like x is of like a key and a value, and then just populate it. Like, well, I don't want to waste time on this because we're far from done, so let's stay here. Let's handle an image real quick just to showcase it, because I think it's really fun. We're just gonna add skimage and import IO, pip install if you ever need to, but it should be in your already installed package. And we're gonna say photo is equal to io.read jpeg, which is the standard name I'm using right now. So what am I doing here? I'm using this this module that we don't need to focus on too much to import an image, okay? But what if I check on the type of this? We have a Numpy and the array, and this is the important bit here. We're going to work on a array that once it's showcased on a plot is an image, but technically as a file it's an ND array. Okay, so if I check on my shape, I get a picture of 153 by 323 by 3. Why? Because it's an image, so images are going to be like 2D, and every pixel of this image is going to have 3 informations for the RGB colors. So you get this, the size, so the length, the height, the length, and the color of your picture. So basically a JPEG is an ND array of positions on a graph and color, which is in the end making it very simple for you to grasp what how you can handle pictures with different programs, right? So now I think we imported, let me check it out. Yeah, we imported matplotlib at the top of our file here. So let's do a plt.image_show of photo, and we're witnessing the beautiful puck in a black and white picture because I didn't want that to be too complicated. So what can I do with this picture? Well, I just kind of wanted to use a few operations on it just to make you guys witness what you can do with this kind of stuff. And so, for example, we're gonna call photo underscore filter, and it's gonna be equal to np.where photo more than 100, 0, and 255. Why am I doing this? Well, first of all, we're using np.where, which is another way of operating on your module. It's not filtering, it's doing an operation if a condition is fulfilled or not. And here what we're going to do, just like on the filter, is just say if the value is over 100, then we're going to say it's now 0 or 255. So if you know your RGB, you know we're going like to the bottom, very low or very high scale of it, and usually you're just turning things into black or white. So what does that do? plt.imshow, sorry, can't type for my life right now, and with my photo filter, and I'm gonna get an error because I didn't run this cell before, sorry. Okay, so I reversed all the colors of my image on this by using np_where. So what you can understand here is that by acting on the ND array of an image, you're going to actually be changing the image itself. You could slice through it to reduce it and just take a chunk of the image. You can do multiple things. But we're not going to do that right now because, well, this is not going to be a 30 minutes long video. So let's finish this up and wrap it with Pandas, which is the main thing I wanted to talk about. And oh no, you know what? I wanted to do this first. I'm so sorry. This is hectic, but I'm just having fun here. Let's just do a plt.show imshow of my photo, and here I'm gonna slice through it by doing not the first dimension, not the second dimension, but I'm gonna get the third dimension, which is the color, and then I'm gonna transpose. So I do it again. Okay, so I transposed my image, and I love this because it shows to you what transpose does. Transpose just took everything that was going left to right and made it go top to bottom. And you can see that what was my first rows here, what was the top of the head, is going first down. The image didn't just go 90 degrees down, it completely switched so that the head is now facing backwards in this manner. So it shows a lot. And by using 0 here, I sliced through the colors and changed everything. The transposing not helping and changing most of the organization of the colors. So it's not as easy because you're going to obviously be messing up with the RGB colors, but I just thought it was really funny. I just remembered that I did that to test multiple things and I wanted to show that to you. So yeah, now with Pandas. With Pandas we're gonna import Pandas as PD, and we're just gonna go ahead and understand how Numpy goes into Pandas. So if I get a, I don't know, fingers, and is gonna be equal to np.arrange 1 to 11, and I'm gonna reshape. This is revision, people. To 5. So what we're doing here is that we're going to generate a ND array of what going from 1 to 11, and then we're going to reshape it immediately to being 2 and 5. So 2 rows, 5 columns. Okay, so fingers, and boom, we get this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 fingers. Youpi. What we're doing here is just generating our array, and we're going to want to make a Pandas data frame out of it. And how does that work? Well, data frames are usually called DF if they are like generic, and we're going to call pandas and create a data frame. So it's kind of annoying because it's data frame with capital D and capital F, and just like for np.arrange or np array, we're going to call a list, a dictionary, a numpy and array, any kind of information, and we're going to turn it into a data frame. The only thing we need to add in there is that we are going to create a table, and this table in pandas is going to have column names and an index for your rows, because you're going from pure matrices, tensors, vectors into actual tables, and all of those tables are going to be able to stock ND arrays, but you're not limited like you are in NumPy to just one kind of value. Every row, every ND array is independent and can be worked with in a very specific way, making pandas so useful for data manipulation and data analysis. So here I'm going to call columns, and I'm going to say just basically, because I honestly don't remember the names of all the fingers in English, we're going to go through first finger, second finger, third finger, and fourth finger, and fifth. Okay, so what I'm saying here is that my column is going to show the first to fifth fingers of each hand, and then you can have the specific numbers of each finger. So let's go here, call df, blah blah blah. And I forgot to put that into a list because obviously this is how NumPy and pandas are going to work. Mostly it's through lists, and so you're going to give it a list of values that is the length of your columns in your data frame. And here we are, our first data frame with you can see the titles that we put in there. We can see the indices that are now created that are automatically 0 and 1. Naturally, when I'm going to talk about pandas, we're going to go a little deeper into that, but what I want real quick is to get into actual projects. So maybe we're just going to learn pandas through the projects, but yeah, good revisions on NumPy. I'm happy some of you people could just do it with me. I hope it could help some people, and I'll see you around. Bye.